Integrity Houston, you are 6 minutes from your 40-minute lunar flyby LOS. From all of us, it's a privilege to witness you carrying the fire past our farthest reach. Thank you. Godspeed.
Thank you for that, Jenny. And thank you to all of you for allowing us the immense privilege to be on this journey together. It's quite amazing. And as we go on this journey, thinking about the NASA mission to explore the unknown in air and space, to innovate for the benefit of humanity, and to inspire the world through discovery. And as you've gone along on this journey with us, hopefully we're doing just those things. And as we get close to the nearest point to the moon and farthest point from Earth, as we continue to unlock the mysteries of the cosmos, I would like to remind you of one of the most important mysteries there on Earth, and that's love. Christ said in response to what was the greatest command, that it was to love God with all that you are. And he also, being a great teacher, said the second is equal to it, and that is to love your neighbor as yourself. And so, as we prepare to go out of radio communication, we're still going to feel your love from Earth, and to all of you down there on Earth and around Earth, we love you from the moon.
Houston copies. We'll see you on the other side.
We will see you on the other side.
Poignant words from NASA astronaut Victor Glover, and a little bit of a love letter from the other side of the moon all the way to Earth. Glover touching on the teachings of Jesus, including to love your neighbor as yourself. We are now less than 3 minutes away from loss of signal with the Orion astronauts. The Artemis II crew will be out of signal for about 40 minutes as they are on the other side of the moon, continuing their work photographing the lunar surface, and they will reemerge, and we will also get this view on the other side. We now expect to regain communications with the astronauts aboard Orion in about 17 minutes. In the meantime, a little overview of how our crew members flying by the lunar far side at an altitude of between 4,000 and 9,000 miles are testing the capabilities of the Orion capsule. Artemis II visualization lead Ernie Wright has simulated views of the flyby using detailed topographic maps of the lunar terrain and photorealistic lighting scenarios. The Artemis II crew members have been using these visualizations to prepare for this historic mission, which is paving the way for future exploration of the moon's surface and beyond.
So the most exciting thing to me about Artemis II is just the return to the moon. We haven't been there in 50 years. Human eyes are going to see parts of the moon that haven't been seen by anyone before. It also recommits us to exploring the solar system in a way that we haven't in a long time. And I think it provides an opportunity for younger generations to understand the excitement of doing that kind of exploration. Artemis is our return to the moon after 50 years. The emphasis of Artemis is going to be, first of all, science, but second of all, learning to sustain a presence on another world. First on the moon, but we're hoping that that's a stepping stone to Mars and other destinations in the solar system eventually. Artemis II will be a flyby mission. It's not going to land. We're testing all of the technology that we've created for flying to the moon since Apollo. A lot of systems have been modernized, and we need to make sure that all of those work. The astronauts will be looking out the window at parts of the moon that have never been seen by human eyes before. They will be flying by the moon at an altitude that's much higher than Apollo's orbits. And so they will see the entire disk of the moon, including areas that are closer to both the North and South Pole that astronauts from Apollo never saw. All of that depends on the lighting, which we really won't know until launch day, but we can practice with different lighting scenarios. It's hard for people to sort of picture that in their mind. If you can make a visualization of it, show them a movie, that helps everybody choose the targets and also practice aiming at those targets. The astronauts have actually been looking at these visualizations through the lens of the camera and practicing aiming at the various targets. This is a map of the surface of the moon, obviously, but it shows what the Apollo astronauts could see in sunlight while they were in orbit. The brighter parts are the parts that they could see. The darker parts, like this entire area here and places that are farther north and south, are places that they couldn't see in sunlight, either because it was nighttime there or because it was beyond the horizon of the astronauts. All of the Apollo flights orbited the moon at a distance of about 110 kilometers. Because the astronauts were flying at such a low altitude, their horizon was actually quite close, and they couldn't see the North and South poles. And this whole area over here was not in sunlight at the time. And it includes this amazing impact feature here called Oriental. Oriental is a very large impact feature. It's about 650 kilometers wide. It's got multiple rings. These are rings that form like ripples in a pond from the impact, but of course it's on a huge scale. The middle of Oriental has that sort of dark basalt lava covering it, like the dark spots that we see on the near side. It's one of the biggest ones that's more on the far side than the near. So seeing it with human eyes and sort of picking out features that maybe you don't even see in robotic cameras is an important goal for the mission.
This live view in the Science Evaluation Room, or the SIR, here at Johnson Space Center in Houston, Texas, just down the hall from where we're at in the Artemis Mission Control Room. Teams continuing to monitor the flyby. The crew continues their observations of the moon, even though they are out of touch with Earth. We expect to hear from them in 12 minutes and 26 seconds. Again, this is approximately 40 minutes loss of signal while they are out of reach of the Deep Space Network. Right now, they are imaging or attempting to image lofted lunar dust. Throughout our coverage, we've talked a lot about the science and engineering behind today's lunar flyby, but we also spoke to the crew about what the moon means to them and how they see its place in human history.